Hi, welcome to the lecture on Introduction to Perceptron. So to have a quick recap about the history of how neural networks have evolved, sometime in 1940s, McCulloch-Pitts neurons evolved, then we had the Hebb's behavior sometime early in the 50s, and then we had Hopfield networks, convolutional neural networks. In 2000, another key concept came into existence called the deep learning. And deep learning with GPUs came into existence sometime in 2010. So if you look at the types of architecture, so you can obviously visualize the neurons in different layers. So you can obviously say, the neurons in the same layer behave in the same manner. So there are certain key factors that probably distinguishes, the behavior of the neurons, like the activation function and the pattern of the weighted connections. These two things basically determine the behavior of a neuron. So when I can arrange the neurons into layers and the connection patterns within and between layers is what is termed as the net architecture. So the neural network basically consists of certain input units, output units, and hidden units. So broadly classified, a neural network can be classified as a single layer or a multi-layer. So whenever you want to probably find out how many layers does a particular neural network has, the input layers, or what I call it as the input units, are not counted as layers because the input units do not perform any kind of computation. So basically, these two kinds of architectures are termed the feed-forward neural network. When I call something to be a feed-forward neural network, it means the signal flows from the input unit to the output unit, which means in the forward direction from the input to the output. If you look into the feed-forward neural network, you have the input layer, the output layer, and the hidden layer in the middle. So the feed-forward model is considered to be the simplest one in a neural network. Why? Because the information flows in only one direction. It's all unidirectional. You can see the arrowheads. It goes from the input layer to the hidden layer to the output layer, and then output is generated. So always remember that in the case of a feed-forward neural network, the data can pass through multiple hidden nodes. That is what is happening in the diagram in the video. But it only moves in the forward direction and will never move backwards. That is what is called a feed-forward neural network. So what is a single layer neural network? A single layer neural network is the most simplest form of a neural network, where there is only one layer of input nodes that will send the weighted inputs to a subsequent layer of receiving nodes called the output. So it is basically the single layer design forms the foundation for systems. This is simple, but this simple foundation will form as a basis for probably making complex neural nets. The input units are all fully connected to the output units, but not connected to the other input units and other output units. This single layer neural network is what is termed a perceptron. So the input units are not considered, so they do not perform any computation. So you consider only the output units. So that is why this is termed as a single layer neural network. What is a multi-layer neural network? A multi-layer neural network has one or more layers of nodes. What I term it as the hidden node, the hidden layer between the input and the output. So if you look at the picture on the video, it has two layers including one hidden layer. Obviously, this multi-layer neural network can solve more complex problems than a single layer neural network. But the single layer neural network has formed the foundation or the basis for building a multi-layer neural network. How do I train the neural network is very, very important and is a key factor in order to obtain accuracy and other statistical parameters. So when you talk of training a neural network, so it is important to note that there are two ways of how you can probably train the neural network. The training is a very important phase because it involves an optimization algorithm that will probably find a set of weights that will map the inputs to the outputs. So the first way is called the supervised training. So you provide the inputs, you provide the outputs, the network will process the input, compare it with the output provided by you against the desired output. There's something called the resulting output and the desired output. So resulting output is what is going to be computed by the neural network. I have given a desired output, it will be compared, and then probably you can find the accuracy, the true positive, true negative, and all other statistical parameters. The errors are then propagated back to the system so that the system could probably adjust its weights and then provide better results. So this process will occur again and again in an iterative fashion till the weights are continuously tweaked in order to get the best result. This is called supervised training. So in the case of a supervised training, it is almost similar to what we do in the university, where there is a faculty, there are a set of students. The faculty probably delivers lecture to the students, clear the doubts and so on. That is called supervised training. So you learn the concept under the supervision of a teacher. The next method is called unsupervised learning. The unsupervised learning is something like this, where, I give you certain topics for you to read, and then I leave it to you to read on your own. I don't assist you at all, and then probably I will test you on the topics called the self-study topics. So I will give you a set of inputs. I will not tell you what is the desired output. Then I test on the questions. That is unsupervised learning, self-study. So what will happen here? The system itself must then decide what features it will use to group the input data. This is called self-organization or adaptation. That is very important. So obviously unsupervised learning is a bit difficult than supervised learning, where when you learn under the supervision of a teacher, obviously it is better result than unsupervised learning. And this is how a system will also learn. Obviously supervised training is easier and less complex than unsupervised training and learning. And this video basically shows you, how, at this instance, supervised learning will differ from an unsupervised learning. I have already told you, I have some training data set. I have certain input patterns. I give it to a neural network. I do supervised training. Then you give the weights and other things. I get the output, that is supervised. Then I compare the outputs with the desired output, and then probably compute various statistical parameters. And in the unsupervised learning and training, I give you the inputs. I will ask the system to do some kind of computation, and I get some output. and then I do not give the the desired output to the system. So this is the basic difference between supervised and unsupervised learning, is what you need to probably understand. So when you talk of a simple neural network, which I term it as a perceptron, this perceptron can also be used for classification through supervised learning. A perceptron is a linear classifier, meaning it's binary, meaning 0 or 1, only two classes. So it enables the neurons to learn and process elements in the training set one at a time. So I have a set of inputs, I have a set of weights, I have the net input function, what's called the summation function, then there is an activation function, and there is some kind of an output. So when you look into a simple neural network, there are two types of perceptrons. It's called a single layer perceptron and a multi-layer perceptron. Whenever you talk of a single layer perceptron, it can learn only linear separable pattern. A multi-layer perceptron or a feed-forward neural network has two or more layers and much greater processing power compared to a single layer perceptron. So basically this algorithm will learn the weights for the input signals to draw a linear decision boundary, you could see. Yeah, there are two classes probably denoted by plus and minus two symbols. I have drawn a line, that basically separates these two classes, and that is what is called the linear decision boundary. So this will probably enable you to distinguish between these two classes. You can call it as plus 1, minus 1, or 0, 1 based on your convenience. I have given it as plus 1 and minus 1. You can also call it a 0 and 1 for your convenience. Nothing wrong in it. So this is an example given. Please note, there are certain inputs, like pixel 1, pixel 2, pixel 3, pixel 4. Yeah. There are a set of input layers marked x1, x2, x3, x4. There are certain weights assigned for simplicity purposes, for explanation purposes. I am assigning equal weights. It need not be so. I am assigning say 0.25 for each of these x1, x2, x3, and x4. So there is a set of output layers, and the output is plus 1 or minus 1. Simple. So if S greater than minus 0.1, you can even write if S greater than 0.1, whatever, based on your convenience. So you do some kind of computation where you write, 1 into 0.25 plus 2 into 0.25 plus 3 into 0.25 plus 4 into 0.25. You will get a value definitely greater than 1. So I assign it as bright. The pixel is bright in nature, plus 1. Else it is minus 1 otherwise. Fine, okay. Now, what is a perceptron learning rule? The learning rule is very, very important in a perceptron. That will decide, the class and other aspects. The perceptron learning rule very clearly states the algorithm would automatically learn the optimal weight coefficient. Then I take the input features, multiply with these weights, and then I will say if the condition is satisfied, the neuron will fire, else the neuron will not fire. So the perceptron will receive multiple input signals. If the sum of the input signals exceeds a certain threshold, what I stated as say minus 0.1, it outputs a signal, or does not return any output, or it might return plus 1 or minus 1 and so on based on the kind of context and application. So this is how, in the case of a supervised learning method and classification, I will be able to predict the class of a sample. Simple. So this activation function can be either step function or sine function or sigmoidal function. And the perceptron activation functions are already explained in my earlier videos. You can probably go and refer to my earlier videos on my channel if you want more clarification on the activation functions. So this is an example of a two-class classification problem, A and B. So what is linearly separable means? Look at this diagram. Consider two input patterns, x1 and x2, two classes, yeah? Let us say one is x, another one is a small circle, hollow circle. Each point with either symbol of x or small 0 circle represents a pattern with a set of values. Each pattern is classified into either one of the two classes. And these two classes need to be separated by a decision boundary. When I say decision boundary, it is a very single line. Yeah, a single line in this diagram. It is nothing but a dotted line represented by L. If I can draw a single line called the decision boundary that could separate these two classes, then I would say this problem is a linearly separable problem. Or the pattern is called linearly separable if I can draw a line. The line could be either dotted or solid. That doesn't matter. The line could either be a dotted line or a solid line. You can draw anything based on your convenience. Here it is a dotted line. If I can draw a line, single line, that can probably, linear line that can probably separate these two classes, then this problem is called a linearly separable problem. So whenever you have any kind of a Boolean function, definitely it will be linearly separable. How? An n-dimensional Boolean function is a mapping from a domain space that comprises of 2 power n possible combinations of the Boolean variables that will fit into a set called 0 or 1, 0, 1 you call it. So each unique assignment of 0 to 1 values to the 2 power n possible input values in an n-dimensional space basically is going to be linearly separable because it will either be 0 or 1. There are only two choices, right, for a Boolean function. Binary logic. So a simple example of a two-dimensional logical AND function is given here. Everybody is aware of the truth table for an AND function. The AND function logical gate very clearly says when both the inputs are 1, the output is 1, else the output is 0. Everybody knows the AND function. I need not elaborate, right? So the truth table is given here, x1 and x2, 0, 0, 0, 1, 1, 0, 1, 1. Output is 0 for the first 3. The output is 1 for the fourth one because both the inputs are 1, output is 1 for a logical AND function. This can be probably demonstrated by using a perceptron. Very simple. Let us say a threshold of 1 because it is simple and convenient. Okay. We need to choose the weights according to constraints. You know, the constraints are like this. Sum of both inputs should be greater than the threshold. Please note, threshold is 1. But each input alone must be lower than the threshold. Yeah. So you cannot say 1.2, 1.4. Wrong. Two conditions are there. Number one, first condition, both in the inputs, the sum of both inputs should be greater than threshold. So 0.6 plus 0.6 is 1.2, well enough, okay. Then each input must be lower than the threshold. Threshold is 1. So input is 0.6, 0.6 for convenience. I can have 0.7, 0.8, 0.5, 0.7, no problem. I cannot have 0.3, 0.4. Why? If you had 0.3 and 0.4, it is 0.7. Sum of both inputs to be greater than the threshold. Threshold is 1. If I add both, now I am getting 0.7, so it is not a good choice. Yeah, you cannot choose like that. That is a condition to choose the weights. Now we can apply the rule. You know, very simple. If A equal to 0 and B equal to 0, what I do? 0 into 0.6 plus 0 into 0.6, 0. Not greater than threshold of 1. So output is 0. Okay. Then A equal to 0, B equal to 1, 0 into 0.6 plus 1 into 0.6. What I get? 0.6. Not greater than threshold, so output 0. Good. Okay, accept. A equal to 1, B equal to 0, 1 into 0.6 plus 0 into 0.6. Again I get 0.6. Not greater than threshold, so output is 0. Good. Now take A equal to 1, B equal to 1, 1 into 0.6 plus 1 into 0.6, I get 1.2. Exceeds the threshold. So what should be the output? Output is 1. Good. So does it satisfy the AND gate or not? Yes, it satisfies the AND gate. What is the output of the AND gate truth table? If both the inputs are 1, the output is 1. Else, the output is 0. Obviously, that condition is satisfied. So, this is how you need to work out. Similarly, you can take an OR gate and try it out on your own. Yeah, it should be OR gate truth table is simple, right? If both the inputs are 0, the output is 0, else the output is 1. You can obviously try it out for an OR gate by choosing suitable weights and writing the truth table and finding out. It will obviously work out. Please try it out on your own. So it is going to be definitely helpful. So this concludes the video lecture on perceptrons. I have given you an introduction to perceptron. What is a feed-forward network? What is a single-layer feed-forward network? How a multi-layer feed-forward network might look like. And I have taken a simple truth table and worked out and shown you how it satisfies the given condition of the truth table and provides suitable output. As a small homework, you can go back and try the same kind of thing for an OR gate as well. Definitely it will work out. So this concludes a simple introduction to the concept of a perceptron, and stay tuned for more video lectures on neural networks. Thank you.